record. And let me get my polls going here. Just give me a second. That's participants, polls. There we go. Yeah, I did cut my hair, actually. Thank you, Connie, for the noticing. Yeah, Brandon, I think like it's one of these things. One of the scariest things you realize as you start to become an adult and you like join the working world is just how dumb everyone actually is. You know what I mean? Like as a kid, you're like, no, man, adults know what they're doing. Like just, and then you become an adult and you're like, nope, everybody is just as dumb as when like everybody is stupid. And you know, the crazy thing is if you want to be successful in life, you just need to be competent. Like literally competence is the baseline of success. And you will be more successful than most of the people out there if you are just competent, right? So it's very crazy. It's a very crazy thing. Yeah, Terrace, I don't know if you you missed it. I gave the class an update as to how that vote was going. It's like 295 to 2. So 295 in favor of changing it to 24 hours and 2 people against. So
the 2 people actually voted against. That's really
yeah,
funny.
2 people voted against. That's how the whole imposter thing came up. Like we were like, who would vote against this? We figured it might have been people who maybe had who were like willing to pay people to, you know, pretend to be them or something, or write the test for them.
But like you can still do that technically, even if it's 24 hours. Huh?
Mm-hmm. For sure, like, but you want to disadvantage everyone else, right? Is the point there? Because if everybody else only has 3 hours to do it, and you know you're going to get a good mark because you're paying someone to do it or something, like maybe I don't know, right?
That's so evil. That not only are you just
it's like, very evil
cheating, you're like you want people to do bad as well. That's kind of horrible.
But I mean, that's kind of like how Post is designed, right? Like
that's true. It is. It's very cutthroat in the first year.
Yeah.
I don't like it. I don't like the way it's structured as much, to be honest with you. But
yeah.
I understand it. It's just it doesn't like promote collaboration between people. It promotes kind of like,
yeah, no, for sure. I mean, like pre-COVID, people used to like talk about, you know, you'd get onto like Reddit or something, and people would be like, "Don't come to class sick," and other people were like, "No, we're coming to class sick on purpose because we're trying to infect everyone else. Like we need people to be sick so that we can make a post, right?" And so like they were deliberately trying to get their classmates sick because why should they suffer, right? Like, oh no, I'm going to fall behind because I'm sick, so now I'm going to make everyone else sick. Yeah, like that was legitimately a thing. This is like, or Dad, I guess you're kind of answering for the survey, but yeah, I assume it really is like, who are the 2 people? But this was a legitimate thing that we see in like really competitive posts, and you know, it's kind of, yeah, it's scary, it's gross. So you know, it's part of the reason too why like I think the university had to shut down. It's because you did have people who, 1, would keep coming to class even if they were sick, and 2, we know there are people who are trying to deliberately infect their classmates, right? So yeah, it's just it is a gross thing for sure, Angeli, but like, you know, we know these people exist, right? Yeah, but you can't prove it. You can't prove that those are the people who got you sick, right? Even though like, yeah, there should be something wrong with that. There should be penalties for it, but yeah, and that's just it. Like you can't catch them. What are you gonna do, right? Where's my pen? Where did I put my pen? I need to write soon. Okay, 30 seconds. 30 seconds, see if you can get this one in. It's a weird question. I don't even know how to read that. Okay, here, let me end the poll. All right, this is fantastic. I mean, we start off in the easy one. I just want to make sure everyone's on the same page. For those of you who maybe didn't get the answer, I'm hoping it's just because you were just like, blah, I'm just going to guess. But if you don't understand how to do this, this is an important thing. Like the next couple of weeks are going to be all about this. So we really want to make sure we're on the same page for this. Okay, but this is sort of like, this is the fundamental theorem of calculus in in a nutshell. So we were told by the FTC, so what are we trying to do? We're trying to do x to the 4 dx, right? That this is going to be f of 2 minus f of 1, where f is some antiderivative. Right? And this is really the power, oh, that's weird, of x to the 4, okay? And this is crazy. Like, I think it's hard to appreciate when somebody has just told you that this is procedurally how we would compute this integral, to appreciate like how insane this is, right? It's really hard to compute the area under the function x to the power of 4, right? Like, even when we talk about figuring out the area of, you know, a circle, that was basically done by integration, right? If you go and you look at like Archimedes' original approximation of this, he effectively did an integral. So this sort of stuff was really hard to do. And then it turns out by calculus magic that the only thing you have to do is find an antiderivative. And if you can do that, like, you're in a good place, right? So this is why we talked about antiderivatives. I think we can find an antiderivative of this pretty quickly. Usually try and take the easiest one you can. So I'm going to take like 1/5 x to the 5. You could use a constant here. You could add plus 10 or something. The constants will just cancel each other out. So try that if you're not certain. I think I mentioned this in the video. So if we do that, we're going to get 1/5. No, that's a 2. 1/5 2 to the power 5 minus 1/5 1 to the power 5. So that's 1/5 times 32 minus 1. So that's 31/5. Right? Voila. That was answer B. Okay, so that's good. Any questions about that? Does that make sense? So for those of you who didn't answer B, right, just make sure that now you're on the same table, you understand why, or on the same page, now you understand why it's like that. Yeah, you can. So the question I got, like, we can just make up any f of x as long as it's an antiderivative, right? And maybe here's an important point. Like, what if we'd used a different one? Right? Like, what if we'd used this antiderivative? So here's a weird one, right? And you'd be like, why would you take that one? Well, let's say we did use this. So FTC would say we would still look at g of 2 minus g of 1, right? And so what would that be? That would be 1/5 2 to the power of 5 plus 71 minus 1/5 1 to the power of 5 plus 71. And notice that what happens is that the 71s, they just cancel each other out, right? Because we get 71 minus 71. So we get the same answer. We still get 1/5 2 to the power of 5 minus 1/5 1 to the power of 5. That's exactly what we had here. All right, so we get the same answer. So really, yeah, exactly. That's what I'm saying about the constant Gerber type. That's a great observation, is that, yeah, there was nothing special about the 71 here. Yeah, absolutely. If you guys want to do that, like, there's nothing wrong with that. You could totally add 99 if you want, you know, respect Gretzky, whatever you're doing. Throw in a pi, throw in like pi, root 2 pi or something weird. But yeah, you can use whatever constant you want. There you go, Jeremiah. 69,420, and voila, you're good to go, right? So the constants always cancel out. You don't have to worry about this. Now, for our purposes, usually this isn't going to be an issue. The interesting place where this comes up is if we were doing trigonometry with sines and cosines, there are a lot of weird places where it can look like you actually have two different antiderivatives, but they actually end up being the same because they're only different up to a constant. That's not really going to come up with us because we're not dealing with any trig stuff, but it is something that does totally happen if you go and take 135, 136, and you're dealing with trig, okay? And so this also applies for any of you who go on to do 233 for whatever reason. This is something you actually have to worry about there. Okay, so let's do a slightly harder one. Okay, so I'm going to ratchet up the difficulty a little bit. Okay, so I got a direct message. I still don't quite understand why the 1/5. So what I'd suggest that you do is, so the 1/5 there is to balance out here. I'm just going to write on this screen so I don't have to, let me restart the poll though. So let me answer this question, direct messenger. Let me do it on this screen here so I don't have to go take the question away. So the problem is that we can't just do x to the power of 5, right? Because if we differentiate that, we get the 5x to the 4. And we don't want this 5, right? We just want an antiderivative of x to the power of 4. So what we're going to do is when we put the 1/5 out front, that ensures that the 1/5 and the 5 cancel each other out. And I just get x to the power of 4 like that, right? Because I'm looking for an antiderivative of that. So the 1/5 is there to cancel out the 5 when it comes down. So is that good? Does that make sense? Perfect, perfect. So, one of the things that I say, how do I turn off annotate again? There we go. So one of the things that I say is, like, anytime you're trying to find antiderivatives, don't worry about what that constant is, right? Like the 1/5 there, just get close. So we could probably guess, when we're looking for an antiderivative of x to the 4, we probably guess it's something times x to the 5, but we don't know what the something is. So start with x to the 5, differentiate it. You get that extra 5, you're like, okay, I need that 5 to go away. Now you know what you're supposed to put in front. Do you know what I mean? Like, don't worry about what that constant is, because you can go and you can fix it afterwards. So when you're trying to do an antiderivative, just get close and then fix it when you're done. Oh man, totally split the whole class.
Mm-hmm.
We got no clue. This one's a little dirty though, everyone. This is a dirty question.
I like it. It's a good question.
Yeah, I like it too.
It's one of these like good understanding ones as well. Like It's not just.
Yeah, you basically shouldn't be doing any computation.
Agreed.
Doesn't it? No. What is it?
It's the absolute value that usually throws them off there. I realized a lot of the integral calculators, the definite integral calculators, whenever you throw an absolute value in there, sometimes they start like doing weird things.
Yeah, it's that's interesting then, because that's a nice way then for us to kind of throw off the calculators. So, but remember, we've talked about x times the absolute value of x before. We did this when we were talking about derivatives. And x times the absolute value of x looks like negative x squared when you're less than 0, and then positive x squared, right? So it looks like yellow is probably a bad color. So it looks something like this. All right, so this is x times the absolute value of x. And on this bit, it looks like x squared. And on this bit, it looks like negative x squared. So that means that if you actually want to compute like let's say the e to the negative x squared term wasn't there. If you actually wanted to do this, you would probably want to break it into 2 halves, right? And sort of like do each half separately. That being said, now it is possible to find an antiderivative of this thing, but the point is this is actually a little bit messy. Okay, so that might not be the way that you want to approach this.
It's fine. We have a very similar question to this in our tutorial today. Like similar concept, just different numbers.
Nice. Okay, let's say 30 seconds. Let's see where that goes.
The polls don't look nice at all.
No, it's like uniform.
Mm-hmm.
Okay, how do I clear this again? Clear. All right. All right, a lot of confusion, right? Like we're not certain what to do here. Okay, so let me show you. And you'll see, I think probably why I was like, oh yeah, this is a dirty question. Is it e to the negative x all squared? It's e to the, yeah, okay, so this is a good question. So when I write this, okay, it means e to the negative and then like x squared like that. Do you know what I mean? Like it's the whole exponent is negative. So I got a direct messenger asking me this. So yeah, whole exponent negative there. Okay, unannotate, and let's go over here. Okay, so we've got the integral from -1 to 1, 3 plus x absolute value of x e to the negative x squared dx. Now, the first thing that we know that we can do is that with an integral, right, the integral of a sum is the sum of the integrals. So we can split this up, right? So we can write this as -1 to 1 of 3 dx plus the integral from -1 to 1 x times the absolute value of x e to the negative x squared dx. Okay, so that's a good start. Now that first integral is fairly easy to compute, right? And you can use the fundamental theorem of calculus if you want, or you can just say, oh, this thing is a rectangle whose width is 2 and his height is 3, right? So this whole thing, this evaluates to 6 plus this thing. So we've got to figure out this behemoth of an integral, which is a pretty ugly looking thing. But the thing is, turns out, actually, you don't have to. That function is odd. So note that x times the absolute value of x times e to the negative x squared is an odd function. Right? Okay, hold on. So a couple people are asking me about how did it become a 6? So there's two things that we can do. So maybe let me just kind of do this as an aside here. So if we do this using the FTC, an antiderivative of 3 is 3x, right? So we would maybe do 3x, plug in -1 and 1. That would become 3 times 1 minus 3 times -1, which is 3 plus 3, which is 6. Or remember, the definition of the integral is it's the area under the curve, right? So if we were to plot this thing, if we plot this function, what does it look like? It looks like this, right? From -1 to 1. And this is a rectangle whose width is, or whose base is 2 and whose height is 3, right? Obviously not drawn to scale, but the area there is 6. So either way, you know, you compute that however which way you want, but either way you get the number 6 out. Okay, does that make sense? Okay, so what I'm going to do here, let me actually, what I want you to do is go into Desmos and I want you to plot this curve. Okay, I'm going to plot it myself here just so I can get an idea of what it looks like, and I'll try and sketch it for you. All right, so this function looks something like, oh, my nose is itchy. So it looks something like this. So it's going along. And it kind of pops up here and then does that. Okay, so it looks something a lot like that. Sure, I'll show you how you can actually figure that out in a second. Well, we haven't done that part yet. So direct messenger, what happens to the equations after the 3? So this is what we're figuring out, right? We're trying to compute what this is right now. So we haven't done anything with that. That's what we're trying to figure out. So it looks like this. And the idea is I'm looking at it between, say, -1 and 1. And because it's an odd function, remember everyone, the area is signed, which means the area under here is the same as the area under here, but they have opposite signs. So this integral is just 0. Okay, and that gives us our whole thing as being just 6. So thus the integral from -1 to 1, 3 plus x absolute value of x e to the negative x squared dx is just equal to 6. And that was, what was that? That was D. Okay. Be specific, like which part do you want explained again? For a person who said, can you explain that again? And then I'll explain the odd thing again after, like how you can check. So Which last part? Like why it's 0? Okay, sure. So the integral of an odd function on a symmetric integral is always 0, right? So note, if f is odd, then the integral from negative a to a, for any a, f of x dx is equal to 0. And the reason for this is whatever f looks like, the whole definition of being odd is that the function to the right of the y-axis looks exactly like it does to the left of the y-axis, but negative, right? So whatever it looks like, let me see if I can draw something here that isn't too crazy. Right? So if I integrate from negative a to a, you always get the same amount of area on both sides, but some of it is above the, oops, shoot. But some of it is above the x-axis. Half of it is above the x-axis, and exactly half of it is beneath the x-axis. So when you integrate an odd function on an interval from like -1 to 1 or -2 to 2 or something like that, the areas always cancel out to give each other 0. Okay? No problem. Now, okay, so the question was, one, how would we figure out if this function were odd? And then I've gotten another question, which is like, how would we do this without looking at a graph? And the thing is, again, you have to be able to recognize that a function is odd. And you're always looking for odd and evenness, because even like when your function is even, it also makes your life a little bit easier. Jeremiah, I'm not quite certain what you're asking. I would be careful. So I got a question saying, can we check Desmos for oddness? And I would say generally no. You want to be careful because functions can look odd in Desmos, but not actually be odd, right? So, but what do you mean is the power of e always negative x squared? I mean, sometimes it is, but it doesn't have to be, right? It could have been negative x. Okay, so how do you know it's odd? So Aziz earlier in the chat said, the definition of odd and the definition of even, or maybe just even. No, yeah, definition of odd. Yeah, you got both, right? So function is odd if f of negative x is negative f of x, right? So if you want to check that a function is odd, we're going to plug negative x into here. Did we do an exercise like this? I feel like we might have done this at the beginning of the year. Did we do something like that? I feel like I remember talking to people about this. Okay, yeah, right. So I think some people are giving me yeses, right? So we've done something like this, and you plug negative x in, and then what happens? Okay, so the absolute value of negative x is just the same thing as the absolute value of x. Negative x all squared is just still, x squared. So if we do all that, we get negative x times the absolute value of x of e to the negative x squared. And notice this thing right here, that's f of x, right? So we got that that's equal to negative f of x, and that's how we got that it's odd, right? And if you play around with these functions, eventually you just learn to be able to identify them. Oh, I see. Okay, so the question was, is this always mean negative everything squared? And the answer is yes. That always means you compute, remember like order of operations, right? Like what does order of operations mean? You do the squaring first, and then you do the negative. So that always means take the negative of the thing squared, right? If you want it to be negative x squared, you really have to put that in brackets. Otherwise, that's not what that means. Yeah, no problem. Okay, so you guys see like how you can, so there's some signs here, right? So if I look at this function, I can just look at its parts, right? And I say, okay, that's odd. This part here is even, and this part here is even. And odd times even, that whole thing is going to be odd, right? And again, like I feel like we did some of that stuff. Remember when we were told like, and I seem to recall some people asking me about this, is like if f is even and g is odd, what is f times g, right? And we did some of those questions at the beginning of the year. Connie, I am hesitant about letting you say, I looked at the graph and the graph is odd. like looking at a graph of a function is usually not enough justification. Just like, if I said find the minimum of function, you couldn't look at a graph and say, oh yeah, I graphed this function and it says it's 2. You still need to provide a mathematical justification that what you said is correct. Because just as with the minimum of the function, I could give you a graph that looks odd that isn't, right? So, and in fact, a good example, well, maybe that's not a great example, but yeah, I can give you stuff that looks odd that isn't, right? So you have to be careful about that. Well, I mean, like, see what I did here? Like this, everything that I did here, this is a mathematical justification, right? Like I have shown that the function is odd. Now, at the end of the day, if you don't feel comfortable doing that and you say, listen, I looked at the graph and it was odd, I would rather you do that than say nothing, right? Just so we're clear, I'd rather you say, I looked at the graph looked odd, so I'm going to assume this function is odd. But really, this is what you should do, right? You should say this function is odd, and you're good to go. Some functions you're just allowed to say are odd. They're obviously odd. Anything that looks like, x cubed, x to the 5. These functions are obviously odd. You can just say that. Right? With slightly more advanced things, you might want to provide some sort of justification, and this is exactly what you would write down. Exactly. And Connie, whether you're trying to show something as even or odd, you'll always just plug in negative x and see if you can relate that back to the original function, right? That's how you do even and oddness every time. Okay, let's see. All right, yeah, let's do 3 next. This probably looks a little bit weird, right? Because it's like, what? F is a function, but it's an integral, right? And that's okay. This is totally a function. It makes sense. Mm-hmm. Yeah, it's kind of surprising. Like, oops, geez, sorry. There's something to be said here too about like convincing yourself that this is a function, right? Because if I plug in like x equals 2, that would be the integral from 2 to 4 4t dt. And you're like, oh yeah, that is a number, right? That's some number, whatever it is. Same thing if I computed f of 7, right? That'd be the integral from 7 to 14. 4t dt, like that. So it is, right? It is a function. And we can define functions in weird ways like this, but that's okay. We're stalling. So I'm going to say 30 seconds. Okay. So that's not bad, right? We have a plurality in A, which is pretty good. And A is the correct answer. So let's see why it's A. And the point is, like, don't freak out, right? Like, if this is a question you get this on a test, you might be like, I've never seen anything like this. Okay, but don't panic, right? Just do what you know how to do. So, okay, why aren't you? Oh, because I've still got annotate on. Clear and then turn off annotate. Okay. So we're told f of x is the integral from x to 2x of 4t dt. Okay, and just like if I'd asked you to do this with anything, what's the first thing we would have to do? Probably find an antiderivative of 4t, right? So for that, I'd probably use like 2t squared, right? So 2t squared is an antiderivative of 4t. So this is going to be equal to 2t squared evaluated from x to 2x, right? Like if there were numbers there, that's how you would have solved this. If this was the integral from 1 to 7, you would have done 2t squared evaluated from 1 to 7. So, don't worry about the fact that these are x's, just plug them in. And if we do that, what do we get? We're going to get x times 2x squared minus 2 times x squared. So that's going to give me 8x squared minus 2x squared. I can draw a better 8 than that. And that's 6x squared, like so, right? And there you go. I think that was A. Right? So there was nothing in this question that was different than what we had even done in question 1, right? In the very first question, when I asked you to integrate x to the power 4, it's the exact same question. It's just instead of giving you numbers to evaluate for the upper and lower bounds of integration, I gave you things with x's, but that shouldn't throw you off, right? Because it's the exact same computation at the end of the day. You just use the error x's instead of, the numbers 1 and 7 and stuff like that. Okay, any questions about that? Of what? Of this function? Not a 4t, no. So the question is, can we say that t to the 5 over 5 is an antiderivative? And it's not, because if we differentiate this, what do we get? We get t to the 4, right? Not 4t. So when it's just 4t, right? Like what should an antiderivative of t be roughly? It should be something that looks like t squared, right? Mm-hmm. Okay, that's good. So I'm warning you, the next question that I'm going to give you, yeah, exactly. Like it's mostly just finding the antiderivative, right? And in fact, the second half of this week, like a lot of the stuff that we do on Tuesday and Thursday is going to be like, what are some really cool tricks that we can use in order to find the antiderivative, right? But once you find the antiderivative, you just like plug stuff in. Now I say that I give you the caveat that the next question we're going to do is a buildup of this one, right? So there's this question, and the next one is going to be similar. So I'm going to ask you to do something not quite the same, but it's the next level of difficulty after this one. Okay, we're going to skip this one. How are we going to do this? Okay, and I'm going to warn you right now, unlike the previous question where you were able to find an antiderivative, this function was specifically chosen because you can't. Okay, this function does not have an elementary antiderivative. So you cannot solve this problem by integrating it first, figuring out what the function is, and then differentiating it. That's not going to work. Okay, so you have to do something else. Brandon, that's true. But if you look at the FTC, you have to be a little bit more careful about what the upper bound of integration is. So here it's x squared. For the FTC, it just has to be x. Karis, it is usually by FTC, but it isn't quite in this case. So, Carrie, yeah, let me maybe state something. So there's a bunch of people who are maybe a little confused. They're like, wait, shouldn't this question be easier than this? So the FTC says this is true. Okay, but the important point here is that that needs to just be an x. Okay, so the lower thing has to just be a constant. It doesn't have to be 0, but it has to be some sort of constant. The top thing has to be an x. And if it's not an x, then you can't directly use the fundamental theorem of calculus. Okay, so we seem to be stalled. Let's do 30 seconds and I'll take it up. Look at that. Sure, Dad. Yeah, we can do that. All right, let's stop that, take a look. All right, that says we're really not certain, right? The class is pretty much guessing because we're about as uniformly distributed as we can. Not a lot of confidence in A, but sure. So the answer is D, just while it's on the screen. Okay, the correct answer is D. Let me get rid of all this stuff though. And let's see why. So there's two ways that you can solve this, and kind of the way that mathematicians prefer to do this is different than the way students tend to do this. I want to show you both ways, just so that you have them both in your pocket. You do whatever makes you feel more comfortable. In my experience, students are usually more comfortable with one way than the other, but that can change depending on the student. Okay, so I want to show you both ways. Okay, so either way here, what we want to do is we want to use the fundamental theorem of calculus, right? That's what we're trying to do. But as I pointed out, our problem is this thing, right? Is that to use the FTC, that needs to just be an x, not an x squared, right? So what we're going to do, here's method one. And these two methods, again, are just the different types of fundamental theorem, right? Because there's two FTCs. Depending on which FTC we're using, we get a different answer. So method one, this is the mathematician way. This is the way that us as mathematicians would do it. Is we would say define f of x to be the integral from 0 to x e to the t dt. Okay, so this is not the function that we're trying to differentiate above, because this only has an x in the numerator or in the upper bound, right? This is not x squared, it's just an x. So that by the FTC, we know, as we've been saying, right, f prime of x is equal to e to the x over x, right? That's what the FTC says. Differentiate the integral, and you just get the function that you're integrating back out, right? Fundamental theorem of calculus. Okay, that's great and all, but how does this help me solve the original problem? Because the original problem doesn't have an x in the upper bound, it has an x squared. Well, if you want to change something from x to x squared, that function is just f of x squared. Right? Let me highlight that for you. So we got some x's here. Right? If I plug x squared into capital F, that means that everywhere I see an x in the original function, I'm going to replace it with an x squared. That is the function I'm trying to differentiate it, or trying to differentiate. Right? This is the function I'm after. And so if we differentiate this thing, we'll get the answer. But we know how to differentiate this. That's the chain rule. Which we can differentiate to get, so we get the derivative of 0 to x squared e to the t over t dt is the derivative of f of x squared. Now I'm going to use my chain rule. So I'm going to get f prime x squared times the derivative of the inside. But I know what f prime of x is, right? That's f prime of x. So I'm going to plug that into here. So I'm going to get e to the x squared divided by x squared times 2x. And then so I've got some x's canceling out, and that's just going to give me 2 e to the x squared divided by x. Okay, that was D. The 2x, remember when we chain rule, we do the derivative of the outside, evaluate it at the inside, times the derivative of the inside, right? So this thing right here is the derivative of the inside function. So Connie, yes and no. So the bottom doesn't have to be 0, but it has to be a number. Okay, it has to be like a 1 or a 7 or a -2 or a pi. Okay, there is a way of doing it where there is an x in the lower bound. There is a way of doing that using sort of the same technique that I used here. In fact, here, let me show you. So if you have something like, let's say we wanted to compute I don't know, x squared x to the 4 e to the x over x, or sorry, e to the t over t. Then what I would do is I would write this as the integral from 0 to x to the 4 plus the integral from x squared to 0, right? And then we know, okay, so this is bad. It's close to what we want, but it's bad because I've got an x in the bottom and a 0 up top, but we know how to flip that around, right? So 0 to x to the 4 e to the t dt minus 0x squared e to the t over t dt. And that would give us f of x to the 4 minus fx squared. And then we would chain rule the whole thing. Okay, so does that answer everyone's questions there? There's still another method, which you guys might find easier, but is that okay? Yeah, sure. Okay, any other questions? Otherwise, I'll do the second method. And again, I think in my opinion, students often find the second method easier. For whatever reason, again, as mathematicians, we tend not to prefer to do it the second way, but it really, there's no difference. And the benefit of using the second method is this question that Connie has asked that I've kind of done here, right? This is an aside. This isn't part of the original question. This question actually becomes easier to do using method 2. I think method 2 that I'm about to do is longer in general, but for these sorts of questions, like the Connie question here, it's actually probably faster. So here's method 2. And again, in my experience, students prefer this a lot more. All right, so let me just rewrite this again to remind you what we're trying to do, right? We're trying to compute the derivative of this. Okay, so the way that we do method 2 is we say, okay, listen, I can't find an antiderivative of e to the t over t. Even if you don't know that this function doesn't have an elementary antiderivative, you could just be like, yeah, I'm having a lot of trouble finding it. So what you're going to do instead is you're going to say, well, let's just pretend I have one. So let's say let capital F of x be an antiderivative of e to the x over x, right? So you're saying, listen, if I could find an antiderivative of this, then I would work it out, right? So that by the other fundamental theorem of calculus, how would you evaluate this integral? Well, it would be f of x squared minus f of 0. All right, so does everyone, before I continue, I want to make sure everyone's okay with what I did there. The derivative, the ddx there is just coming along for the ride. It hasn't done anything. The thing in square brackets is what I've evaluated it, and I've evaluated it using the fundamental theorem of calculus, right? If you have an antiderivative for the integrand, then to evaluate the integral, you just plug the top and bottom numbers into it and subtract them. Okay, so is everyone all right with that? Why when it's t, the power becomes, okay, where, Jeremiah? Like, is it this too? Okay, so here, maybe let me just put this on the side here. All I'm using here is this. Okay, and what is b in this case? It's x squared. So I'm not, I'm just plugging that number directly in here, right? Like as this B goes here, that x squared is going right there like that. So it's not about like it becoming a 2 magically. It's just that I literally put that number into my antiderivative. Same thing with the 0, right? I just took the 0 and I went boop and plugged it into there. Yeah. Does that make sense? Okay, cool. All right, now I want to differentiate this function. So when I differentiate f of 0, I get 0, right? F of 0 is a constant. There's no x's in it. So when I differentiate f of 0, I get 0. So this now just becomes f prime of x squared times 2x. This should look very familiar, right? And then we said f prime, because capital F is an antiderivative, f prime is just our original function. And we get the same thing. Right, like that. All right, see you, Aziz. Okay, so some students like this more. Again, hopefully you can see, like, if you want to do Connie's question this way, try it, and you'll see that it's almost no extra work, right? Like Connie's question is basically the same amount of work. It's just you replace the 0 now by whatever the bottom function is, right? Okay, so same sort of thing. Here, let me maybe write this out in more detail. Okay, so this is the derivative of f of x squared minus the derivative of f of 0. Now, this is just a constant, right? So that whole thing is 0. And then this is exactly the same as we did. This is the same as what we did above, right? Remember where we used the chain rule, right? So we do the derivative of the outside times the inside times the derivative of the inside. Right? Like it is the exact same step as this thing right here. Right, exactly. Yeah, f of x squared is a composition. The outer function is big F, the inner function is little x squared, right? Or just x squared, not little x squared. Cool, great. And so you see, like they actually reduce to the exact same thing, right? They become the exact same, not only the answer, but eventually you arrive at the exact same thing, which is this right here, right? And this right here. Right, they are the same. You end up at the same place, regardless of which one of these things you use. So, it doesn't matter. Okay, so use whichever one you prefer. All right, everyone, so that takes care of us today. I know some of you have to run because you have other classes or tutorial, wherever the case is. So thank you for coming. I'm going to hang around for office hours here, and a couple people have asked for some questions for us to take up. But yeah, if I don't see you because you have to run, I'll see you on Thursday. And then otherwise, let me open the textbook. Okay, so I was asked for a question like the writing assignments, i.e. an optimization problem. Let's see, can I think of one? It really depends, right? Because depending on which writing assignment you're doing, the style is a little bit different. C, okay, a lot of people are asking about C. C is the Dominion one. People are asking about A as well. Okay, yeah, you're all inundating me with a bunch of them. Let me make one up here. Let me see if I can't, or let me just quickly search my notes and see if I can't find another one. Okay, so, and yeah, remind me what the other ones are. So one of them is the power, the telephone tower one. Is that, which one is that? Is that A? That one's B. And then A is the fence and the ladder. Right, okay. So they're all a little bit different, but they're all kind of structurally the same, right? And the way that they're all similar is that ththey're all constrained optimization problems. So they all, again, right, they all kind of look like, find, the max. Geez, no. So they all look like find the max or min, depending on what you're doing, of some function of two variables where there's another function which constrains them. Right? And every single one of those times, and you might be freaking out. You're like, what do you mean X's and Y's, right? But every single time, what you're going to do is you're going to solve g of xy equals 0 for either x or y, right? Then you plug that into f. Find the max or min, and then you're done. Okay, so the things that are probably closest to this, maybe let's do like 7-30. Does that look close to it? Yeah, let's maybe do 7-30 as an example, which is in some sense like agnostic. It's kind of similar to everyone's problem, or equally dissimilar maybe. Okay, so hopefully take a second, pull it up so that you have it in front of you. I'll read it out loud, but it goes, you are standing at the origin. Okay, so we're going to draw our graph. So you're standing at the origin. This is us. And your friend, you're watching a speed skating race, and your favorite competitor, Carl Friedrich Gauss, is fast approaching. From where you're standing, he takes the path f of x equals 4 over x. Okay, where x is between 1/2 and 4. Right, so this is a half here, and this is like 4 here. Okay, what is the shortest distance that he comes from you? Like, when is he closest to you, basically? So you can imagine that looks something like this, right? So the question is, when is he closest to you? When is Carl closest? Or equivalently, another way we could say this is, what is the point on the curve y equals 4 over x, which is closest to the origin, right? That's the equivalent question. Okay, so the thing that we're trying to optimize is distance, right? So we're trying to find the min of the distance from the origin, right? Because that's where we're standing, to the point xy, where y must be equal to 4 over x. Does everyone agree with that? Does that make sense? So I'm trying to find the coordinates which are closest to the origin, but I can't just choose any coordinate, right? Specifically, those coordinates have to lie on the blue curve that I've drawn. You're told, so I got a direct message saying, how do you know it's 4 over x? If you pull up the question tells you it's 4 over x, yeah. Okay. So does someone remember what is the distance equation from here? Let's make our lives easier. From 0, 0 to a general point xy. Like if I give you any point xy in the plane, how do you figure out what is the distance between these 2 points? Square root x squared plus y squared? Yeah, exactly. Does everyone agree? So maybe let's call that d of xy. That's the square root of x squared plus y squared. You guys remember that? That's something that should have been in high school, but it is possible to figure this out kind of on the fly as well if you want, right? If here's the xy plane and you're standing at 0, 0, and there's some point over here, x comma y, and you want to know this distance, well, this makes a triangle, and by Pythagoras, that's the length of that triangle, right? That's the hypotenuse. So the distance is x squared plus y squared. Now, yeah, so is everyone okay with that? Are there any questions about that? That's the distance from the origin to an arbitrary point. Everyone's good? Okay. Now the constraint is xy can't be any point in the plane, right? It can't just be whatever point you want. Otherwise, you would just take 0, 0, right? Like the closest point to 0, 0 is itself. Instead, I have this constraint, which is namely that the point has to lie on the blue curve. Now the points on the blue curve satisfy, so the points on the curve y equals 4 over x are of the form x 4 over x. Yes? Right? Because like this equation is literally telling you what the y coordinate is. So it says you give me the x coordinate and here's how you calculate the y coordinate, right? That's what the graph of a function is. Is that okay? So in this case, right, like we've already, this is our g of x, y, g of x comma y equals 0. We already have y as a function of x. So why don't we just plug that in, right? So we're going to plug that into our distance function, 4 over x, like this. And we can expand that out. I get 16 over x squared like this. And, maybe we want to give it a common denominator. So we'll get what? So we're going to get square root 16 plus x to the 4 all over x. Okay, and then you differentiate this and you find the max, or you find the min of this function. Now there's a dirty trick. I guess we can do it if you want. Do you guys want me to finish this question and just show you how you'd go through the process? Well, okay, it's divided by the square root of x squared, right? Yeah, and exactly. And in this case, you might make an argument, oh, it's supposed to be the absolute value of x, but because x is positive, it's just x, right? Curdy, no, there's no more simplification that we can do to that square root, right? Because we don't, for example, the square root is not additive, right? Like the square root of a plus b. A lot of students make this mistake. Everyone be careful not to do this by accident. Okay, these two things are not equal. So we can't do anything more about like that sort of simplification. That's definitely a way students get burned a lot, but it's just not true, right? Like if you check, the square root of 2 plus 2, that's the square root of 4, which is 2, but the square root of 2 plus the square root of 2 is like 2.8. Right? So yeah, they're just not, it unfortunately doesn't work out. Okay, and so if we like continued, right? So now we differentiate this function with respect to x, and it's a bit of a mess. And if you want, I'll show you a trick to this in a second. But so we have to differentiate the numerator. So derivative of the top. So it's going to be 1 over 2 root 16 plus x to the 4 times 4x cubed. So derivative of the top times the bottom minus the derivative of the bottom times the top, all divided by the bottom squared. Okay. So let's give the numerator a common denominator. So let me just write this out. So this is going to be 2x cubed. Let's write this like this. So let's write this as 1 over x squared 2x cubed divided by the square root of 16 plus x to the 4 minus root 16 plus x to the 4. So that's going to be 1 over x squared 2x cubed minus 16 minus x to the 4, right? Like this. Oh, sorry, this should be an x to the 4, right? Somebody, I'm sure, is yelling at me in the chat. Oh, maybe nobody picked it up. So this is going to be x to the 4 minus 16 divided by x squared root 16 plus x to the 4, right? You want the critical points of this, so you'd set this to be equal to 0. That implies x to the 4 is equal to 16, which implies x is equal to what, 2? And then we just have to check that it's a min, right? So you check your endpoints. X equals 0. And why is my, no, and x equals 4. And then just see which of these gives you the minimum value. Okay, so does that kind of make sense? I guess there's actually a lot there. You're right, Kelly. It would be 2 and negative 2, but I guess I didn't write it down. The question explicitly says that 1/2. Oh, no, there it is. So you're right. If I were solving that, it would be x is equal to +2 and -2. But we're told at the beginning of the question, and the thing that I circled in yellow, that x has to be between 1/2 and 4. So, I mean, I maybe cheated a bit because I was like, I know that I'm going to reject the -2 solution. You know what I mean? Because we know that x has to be positive. So I just kind of immediately threw the -2 solution away. But if you want, definitely you can say, look, x has to be plus or minus 2, but we reject the negative solution because of the restriction on x. But otherwise, you're totally right. Okay. Now there's a slick trick here I want to show you all as well. Now, if this bugs you, don't worry about it. This trick makes your life a little bit easier and makes the algebra easier. But if it bugs you and you're worried about using it, don't worry about it. Okay. So basically, when we get to here, what I would personally say is I would say, look, the square root is smallest when the thing in the square root is smallest. Do you agree? Does that make sense, everyone? Like, when is the square root the smallest? When the thing inside the square root is smallest, right? Because the square root is just monotonically increasing. So it's smallest when the thing inside of it is smallest. So if I'm trying to find the min of this function, it actually is enough to find the min of just the thing inside the function. And now there's no square root. This is so much easier to differentiate. Or sorry, that should be squared. Same thing, right? When is the square root the biggest? When the thing under the square root is the biggest. Does that make sense? This doesn't work for all functions. What you need, everyone, in order to be able to do this, what you need is that the outer function is strictly increasing. Okay, so the square root function, right? If you graph the square root function, it looks like this, right? It's always getting bigger. So you can do this as well for functions like log, right? So this is square root of x. You can do this for log x. You can do this for like e to the x. Okay, if the outer function is a strictly increasing function, it's, what do you mean in reverse e? Like 1 over e? Or e to the negative x? Or, well, strictly speaking, the inverse of the exponential function is the log. Okay, well, yeah, there's a couple here that you could do, right? So like e to the negative x, yeah, which is which? So yeah, 1 over e to the x and e to the negative x. So that's a reflection. So it looks like this, like that one. So if the function is decreasing sign, you kind of have to do the opposite. Okay. So when it's increasing, the function is maximized where its inside is minimized. Does that make sense? Like think about it like this. So that was a little bit of a weird statement. Think about the function 1 over x. When is 1 over x biggest? It's when x is the smallest. Does that make sense? Right? Like we know that, right? The smaller the denominator, the bigger the number overall. And the bigger the denominator, the smaller the number is. And that's because 1 over x is a decreasing function. So when your function is decreasing, you have to flip them. To find the max, you have to find the minimum of the inside. And to find the min, you have to find the maximum of the inside. If that's confusing, don't worry about it. But if your function is strictly increasing, the min corresponds to the min of the inside, the max is the max of the inside. If your function is strictly decreasing, the min of the outside is the max of the inside, right? And you have to flip them. Okay, this is an interesting question. So for assignment A, to find the min length of the ladder, do we start at the top of the ladder? Do we start at the top of the ladder to top of the building, or on the ground to the top of the building? So I would start at the ground. It really doesn't make a difference. You can do it either way, but I would start at the ground just because that's how humans actually put ladders down. But you don't have to if you don't want to. I think the critical thing to realize for assignment A is that the ladder has to touch the top of the fence. Do you all agree? So for those of you doing A, do you agree the ladder has to touch the top of the fence? Because if it doesn't, right, if the ladder is strictly above the fence, then you can move the ladder closer and shrink the length of the amount of ladder you need. So the ladder has to be right against the fence, and it basically has to be touching the top. And when you realize that, it makes the math much easier. Yeah, no problem. So does that help everyone? Do you see kind of what you need to do? Like you have to model the situation. You have to figure out what you're trying to maximize, what you're trying to minimize, and then actually do it. So for those of you doing, for example, let's say C, right? So you're doing the Dominion question. What are you trying to maximize? What's the thing that you want to make big? Yeah, so Jeremiah, I don't know if that's like, are you saying that these are riddle questions? Or are you saying that like, this is abstract? I'm not certain which is you're saying is which. Because I wouldn't say these are riddle questions. These are like modeling questions in some sense, right? But I don't know if that's what you meant. And I totally get it. Like some people don't like abstraction, like abstract mathematics, but you have to realize like an important part of what we're trying to do with you in this class is get you comfortable with abstraction, because you're right. Most of the abstract stuff you learn in this class, you'll never use in your life, right? Like 100%. Who cares about most of the stuff that you're doing? But the idea of being comfortable with abstraction is a powerful like intellectual tool, right? And yeah, abstraction is hard, and in a lot of cases it sucks, but that's a thing that math is really good at doing, is getting you to think abstractly and strengthening that part of your brain, right? So lots of times students are like, why the heck are we learning this stuff? Like I'm never going to use it in my life. I mean, first of all, that's been true since like grade 4, right, of most of the math that we teach you. And totally, don't get me wrong, I think the high school curriculum is largely crap. But the point of math is often to make you better problem solvers, better critical thinkers, and better at abstraction. And sort of the medium itself isn't as important. So Jack, right, we're trying to find the maximum, right, okay, perfect. So you're trying to maximize your victory points, and your constraint is the amount of gold you have, right? Because if you have lots of gold, then you can just buy as many dukes and duchies as you like. So what you probably want to do is say, suppose I have this many dukes, and suppose I have this many duchies. And if you know how many dukes and how many duchies you have, they'll be variables for now, right? Like X and Y. If I have X dukes and I have X and I have Y duchies, how many victory points do I have? And then how much gold did it cost me to buy them? Do you know what I'm saying? And those are your equations. One of them is I want to maximize this equation, and the other one is your constraint. what do we come up with 2 equations? So for B, well, Gerber-Tapp, try writing it out, okay? So Gerber-Tapp, what I want you to do, let X be the dukes, let Y be the duchies. Now read the question and figure out, if I have X dukes, how many victory points do I have? If I have Y duchies, how many victory points do I have? And then how much money did it cost me to buy those, right? And if it helps, don't have them be X and Y, actually choose numbers, right? If you have 3 dukes and 4 duchies, how many victory points do you have? Right? And then do that for a couple of different numbers until you see what the pattern is. But if you read the question, try and figure out like how you would do this for an arbitrary X and Y. Okay, so for writing assignment B, would we come up with 2 equations, one for the cost of operating and another for the revenue generated? Exactly, yeah. So for B, right, figure out like profit is revenue minus costs, right? So figure out the revenue that you get from building a certain number of towers, figure out the cost of running those towers, and then find the number of towers, which maximizes your profit, right? Ooh, Jeremiah, so you're saying that's your final answer? Because you could do that. That's one of the endpoints, right, Jeremiah? Like that's one of the extremes. Obviously, the other extreme would be all dukes and no duchies. I think the optimum is somewhere in between, though. Just like from my memory of it, I recall the optimum being in between. For writing assignment A, do we have to find the second derivative to justify? If you can find, you could use the first derivative test, Emma, if you wanted to. You can use the second derivative test, or if you have 2 clearly defined endpoints and you just wanted to like check the endpoints versus, checking the intermediate one, then that would be fine. But usually you do need to provide some sort of justification and evidence that your answer is actually a minimum, right? Because the fact that you're a critical point doesn't guarantee you're a min. It could actually be a max. So there should be some sort of justification there, right? Yes, Davin, you're right. There is a sense in which 4B can be done with like a single variable immediately, but in the same sense that this question that I'm doing here about Gauss, I could have, instead of writing it here as dxy, I could have just done this as a single variable right from the beginning. Do you know what I mean? And it's totally okay. You don't have to say it's a function of 2 variables. If you're comfortable going straight to it being a thing of 1 variable, that's totally okay. And you're right, it's not always a constrained optimization problem. There's a real sense in which B is just a straight max or min, but the problem really comes from modeling it instead. So not every optimization problem looks exactly like this, Davin. So that is a good observation, but there is a way you could sort of make it look like this, right? Is the cost per tower the per tower cost and the maintenance cost? Yes, yeah, right? You have one-time fixed costs for building each tower, and then you have monthly costs for maintaining the towers. And yes, and yeah, you add them up. But right, the monthly keeps recurring, but the building the tower is just one time, right? So you don't worry about that on a monthly basis, but the monthly costs you do worry about 12 months. That's why it's given you a 1-year horizon. I did that for C, assuming a number for dukes and duchies, but I couldn't find an equation to summarize them all. So Jack, I'm not certain what you mean. What equation did you get? So let X be your dukes and Y be your duchies. What is your, here, let me write that down. So private message me, right? Try not to give it away. So X equals dukes, Y equals duchies. What's your equation for victory points? Can I explain the monthly cost? Okay, so which part? So it's like, if you have, let's say, T towers, what's the monthly cost of that many towers? Same. Does this mean that Jeremiah, that might be too meta. I can't remember if it does work out to be that. But generally, so here's the thing. So let's say you have 3 duchies, right? Each of those is worth, 3 points. Great. If you have 4 dukes, for every duke, you got 3 points. That means you have 12 points for dukes. Does that make sense? So it's not, each duke gives you a point per duchy. Does that make sense? So you see how it's competing now, right? Because duchies are worth more each, but dukes begin to multiply, right? Dukes are multiplicative. So if you had 5 dukes and 3 duchies, the dukes by themselves are worth 15 points, right? So that you can see like it's going to be somewhere in between because you need some duchies, right? Because if you have no duchies and you have all dukes, it's useless. So you need some duchies, but you probably want some number of dukes as well. So where does that compromise occur, right? You probably want 1.25, same, right? Otherwise, it's like you're just computing interest, right? Like per tower. Yeah, Davin, exactly. Yeah, perfect. So per tower, it costs you 25% more. It's like a compounding interest thing, right? So the total cost, so the first tower is 500. Second one is 500 times 1.25. The third tower is 500 times 1.25 squared, right? Yeah, it's the compounding interest formula. It's exactly what yeah. So does that fix it for you? You're good after that? Okay, Jack, your equation looks good for me. Now, what is your number of no, Jack. That's you've conflated your 2 equations. So Jack, your left-hand side there is victory points, but your right-hand side is gold. And those aren't equal, right? So the left-hand side of your equation is the victory points. Now, what is the equation for how much money you had to spend? Does that make sense? So you're trying to optimize your left-hand sided thing, right? You agree your left-hand side of your on your equal sign is your victory points. Okay. How much money did it cost you to buy X dukes and Y duchies? Like, what did that cost? Yeah, Simon, you're good? Like, is that the thing that you were, so you said that's what you were missing. So I hope you're good. Okay, cool. Yeah, no problem. Now, Jack, exactly. And that has to be equal to N, right? That was your cost. That has to be equal to N, right? Because that's how much gold you have. The first one's not an equation, right? I mean, it has an equal sign if you give it a name, but the first one is just something like, 23. Like I'm writing down something wrong so that I'm not giving away answers. But 72x squared y. This isn't an equation because it doesn't have an equal sign, but it's an expression. But yes, one will be an equation, right? Your budget constraint is an equation. And then the other one is just a function that you're trying to maximize subject to your budget constraint. No problem. Okay, Brandon, Sophie. Yes, yeah, that's what it would be for 2 towers. Yeah. And then, what is it for more towers? Emma, I found the minimum length. We're working out another variable, one that changes the equation in the line formed by the ladder. I mean, Emma, you can. What I would do is I would recommend that you post it on Piazza. But remember, like, correctness in your writing assignment isn't worth much, right? Like, it's a writing assignment. What's far more important is your level of explanation. With that being said, if you do want something specifically to sort of be looked at, throw it on Piazza. Obviously, post it privately, right? But throw it on Piazza and we're happy to take a look at it. I'd say do it on Piazza just because there are more, like, we're all looking at Piazza and we can tell you if, like, we see something that's obviously wrong. We tend not to confirm answers, but we can tell you if there's something obviously wrong. Kelly, the $50,000 is per tower. So if you build 2 towers, it's 50,000 times 2. So that doesn't include the like monthly operating costs. That's just like a one-time expenditure that it actually costs you to build it, right? So it costs you $50,000 to like put the tower up, and then it costs you X amount of money to hire a technician and go out there and make sure everything is fine every month. So if I had one, so Gerber Tap, I'm reading your thing now. If I had one duchy, I get 3 points. One duke, I get 1 point. No, if you have two dukes, Gerber Tap, you get 2 points. So each duke is worth 1 point per duchy. Okay, here, everyone, let me, so for those of you doing C, there's needs to be important clarification here. So let's say you have 3 duchies and you have 4 dukes. Okay, the dukes in this case are worth 12 points because each duke is worth a number of victory points equal to the number of duchies you have. So each duke is worth this many points. So Gerber Tap, does that clarify your thing? Yeah, exactly. In this case, it would be 4 times 3 Sean. Yeah, right? Because you have 4 dukes, each is worth 3 points. So you'd have 12 points, right? For version C, do we write an equation? Yeah, Sean, that looks great. Yeah, that's exactly what you do. And then you try to maximize your victory point expression, right? So you have to come up with that as well, but your expression for the like gold constraint there is perfect. Brandon, more generally, would it be yes? That looks right. My only concern is that it's only out of 3. So even if your whole process is right, no. So no. If it's out of 3, only one of the 3 marks is for correctness. Okay, so like of the 3 marks on your writing assignment, 1 is for your writing, 1 is for your feedback, and 1 is for your correctness. So you could get the answer totally wrong, but if you do a great job explaining and you do a good job with feedback, you get 2 out of 3 immediately, right? If you make a small mistake on your correctness, then you should get most of the marks, or maybe only half, depending on the severity of the mistake, but you should get most of the marks for doing that. And with any luck, if you do a good job explaining it, your partner should be able to catch if you've made a mistake, right? Like that's kind of hopefully what's going on there. But yeah, you don't get 0 out of 3 if you get the question wrong. You would get 2 out of 3 as long as the other 2 parts are good, right? We want to emphasize the writing more than the correctness there. Would revenue in 4B, wait, sorry, what's 4B? Oh, writing assignment 4B. Yes, per month, same, right? That's what it'd be per month per tower. But like as you have more towers, that number will go up. Okay, so Gerber Tap, what I need you to do is give me, so again, you have, right? Let's go back up here. Where did I write it down? Okay, so Gerber Tap, X, dukes, Y duchies. In a private message, what is the number of victory points you have? Okay, send that to me. How do we solve for it without knowing the endpoints? How do you solve for what? I mean, like your endpoints are usually given to you. Like in this question that we just did about the speed skating thing, you were told your endpoints X is a half and X is a quarter or is 4, right? Yeah, in some cases you're right. There are no obvious endpoints. In that case, you can't do endpoints, right? There are some functions where there is no endpoint solution. In that case, though, you really have to use a first derivative test or a second derivative test. But if there are endpoints, the endpoints are usually in some sense obvious from the question, and then you can go from there. Davin, yes, you should have an exponent. In particular, your cost function should have an exponent, right? So first tower is 500, second tower is this much, third tower is this much, fourth tower is this much. It's like a compounding interest thing. Yeah, no, your P of X is right. It is revenue minus cost, but your cost function should have an exponent in it because your costs increase, your monthly costs are increasing exponentially. Yeah, okay, cool. So if I write another equation for points, and yes, yeah, Sean, exactly. And if you do that, you'll get the right answer. Yeah, you've got all the equations there. You're good to go. You just have to solve one equation for x and y, plug it into the other one, differentiate, do your usual stuff, and you'll be good to go. No problem. So close. How many points do you? Well, okay, wait. Where'd the x is dukes, right? I think you've switched x and y here on me. Do you want x to be duchies? Is that what you wanted? Gerber tap? Because y is the 3 there otherwise. Okay, sure. No, it's fine. I'll switch these. Okay, x is duchies. Y is dukes. Okay, so the first part is fine. Why is it just y? What did we say? What did we say the number of points in this scenario was? Just from the dukes. And look at your equation. So this should, if we do 3 duchies and 4 dukes, this should be 9 plus 12 points, right? Because you get 3 points per duchy, and then the dukes gave you 12 points. So look at your equation again and just double check if you have the right answer. Okay. But where did the 4 come from? Kelly, yeah, that looks right. Yeah, for your monthly cost though, right? Not your yearly cost, but Kelly, that looks like the right cost function for every month. Yeah. So Gerber tap, if I change this to 5 dukes, it becomes 9 plus 15 points, right? What's going on? So the problem, Gerber tap, is that like the number in front of your y is changing, right? Here's what I want you to do, right? Remember, x is your duchies, y is your dukes. How many points do you get? Like, where does the number 15 come here from in terms of x and y, right? If you've got x duchies and you've got y dukes, how many points did the dukes give you? How would you compute that from x and y? How would you compute that from 3 and 5? Okay, so Theodore, I'm reading yours now. I mean, that's definitely the right way to go. I'm not 100% certain about your equations after that, just because I don't remember the exact solution. But so we get this, and plugging in, we get what is f of a here, Theodore? Like what is that? Oh, is that your length function? Is that, yeah, what is f? I'm not certain what f is. So Jeremiah, what are you asking for? Like, should both cards produce the same amount of points? No, I don't think so. No, I would just be careful about making any assumptions like that. Like, just let the math tell you what the answer is. You know what I mean? Like, once you figure out what your budget is and once you figure out what your number of victory points is, the math will figure it out for you. And you don't have to make any assumptions like that. Right, Gerber tab. That's phenomenal. Exactly, you have it. Now, change it so that if you had X dukes and Y duchies, what would the answer be? Like, look at exactly what you wrote down for me, and change 5 dukes to X dukes and 3 duchies to Y duchies. How would you compute your number of points? All right, hold on. Let me just, because I'm having a little bit of trouble seeing the diagram in my, without redrawing it, and I don't necessarily want to redraw it because that would sort of deprive you from that. Oh no, that's A. I don't want A. Which one's ladder? Ladder's B? No, that's tower. Tower is B. Why are these the same? All right, hold on. Yeah, Gerber tab, phenomenal. There you go. Now check it, right? Double check. Does that work? Is that what you actually want? I mean, you have to include the duchies themselves now, right? That's just the dukes. Okay, so Kelly, sorry, let me read yours quick. 500. No, not to the power of 12 though. Each month the cost is fixed, right? So if it costs, say, $700 every month, then you would just multiply that by 12 to get the yearly cost, right? So just multiply by 12, don't exponentiate. So Theodora, yeah, so I'm not, so like you say, you kind of correctly set up a triangle. You've managed to compute the length of the hypotenuse. Now, from there, what is this thing you're saying? 2a divided by a minus 1 equals b? I'm not quite seeing that. Oh, I see what your f is. I see. So I don't know how you got 2a divided by a minus 1 equals b. I mean, that might be true, but can you tell me how you got that? Christian, why are you multiplying the 50,000 into that number? And also that number should depend on T somehow, right, Christian? Like, as you build more towers, that cost should go up. And right now, like, is that for 1 tower or 2 towers, or is that still T towers? Like, I thought maybe I should find A and B when the derivative, and then see through the Pythagorean theorem. Okay, so Theodora, the only problem there is that you don't know how to differentiate. So you're right, okay? So Pythagoras is still good, right? Like, you've got your building, you got your fence, and you've got your ladder, right? And you said, like, maybe this is A and B and this is C, and then Pythagoras is doing it for you. Okay, great. So like you said, you kind of have 2 variables here, right? And the problem is you need to find some way of expressing them, and you've tried to do that, and you gave me this equation. My only problem is I don't know how you got the equation that you got relating A and B, right? But here's the thing. If you know that C has to go through the top of the ladder, then you know exactly what the equation of this line is. And so you can then use the fact that you know what the equation of this line is to write A in terms of B. Does that make sense? Yeah. Yeah, Gerber tab, perfect. There, so that's your number of victory points. Now, how much did it cost you to buy that many dukes and that many duchies? No problem, Theodore. Okay, so Gerber tab, tell me now, So that's the function you're trying to maximize, right? That's your victory point function. So that's what you want to make as big as possible. What's your constraint? What did it cost you to buy that many dukes and duchies? Okay, so Christian, one tower only costs $500 though, right? So you don't need to worry about the 25% like increase. So your one tower costs you $50,000 to build, and then it costs you $500 per month, and then you multiplied it by 12 months, right? That's a bad two. So that's how much your yearly expense should be for one tower. For the question, said it charges cell phone service 40 months. So would it charge for each customer? It costs, it's $40 per, so Kelly, it's $40 per customer per tower. So each tower has 500 customers, I think I said, right? So 500 times 40 is your monthly revenue for each tower, right? So each tower had 500 people. Each of those 500 people is paying $40 a month. No problem. Great. Yeah, phenomenal, Gerber. And that has to be equal to n, right? Because that's how much gold you have, right? So that has to be equal to n. And so now you have your constraint equation, Gerber, right? You have this is your constraint is that has to be equal to n. Use that to solve for either x or y. Plug that into your victory point equation, and then do our whole differentiation, find the critical points, yada, yada, yada. Does that make sense? There's weird times when the chat just goes insane and I can't keep up. And then there are times like now where the chat is just totally stopped. Like nobody's saying anything. Maybe it's because people are thinking, which I would love. So Gerber, that equation is what you use. So your victory point equation has both x's and y's in it, right? And the problem is that you don't know how to solve, like maximize functions of two variables, right? You only know how to maximize a function of one variable. So what you have to do is you have to use that equation with the n in it in order to solve for x or y so that you can plug it back into the victory point equation. And now your victory point equation will only depend on one variable, and you'll be able to find its max or its min. You're trying to build that constraint function that you've just written down for me. You're trying to put that into your victory point equation so that you only have an expression with one variable inside of it. I don't know why you're taking a power of x, Kelly, and like, you know, it doesn't, like 20,000 squared is gigantic. Do you know what I mean? So you don't want 20,000 to the power of x, right? Like if you have two towers, then you're reaching 1,000 people. And if you have three towers, you're reaching 1,500 people. And if you have four towers, you're reaching 2,000 people. Does that make sense? So that's how you, and then each of those people is paying $40. No, you, Gerber Tap, in this equation, or in this question, n is fixed. It's not a variable. If you want, solve the problem with n being equal to 100 or something and see what answer you get. But n is not a variable. It's just a fixed number that we didn't give an actual number to. Do you know what I'm saying? Like it's not a variable. You don't have to solve for it. It's just a number that we didn't specify. It's just n, whatever n is. Yeah. Right, just like when we were doing like, you know, like finance, right? We'd say like, let R be the interest rate. R wasn't a variable there. It was just, it was a number, but we just left it sort of, left it as a letter. So it could be general. So your answers will probably depend on N, right? And then you can say, oh, if I have 20 gold, if N is equal to 20, I know how many dukes and duchies I should buy. But if I have 100 gold, I know how many dukes and duchies I should buy. And yeah, I mean, on this note as well, if any of you if you haven't had a chance to play Dominion, don't worry. It doesn't actually really involve any math. It's a really fun game if you ever get a chance to it. If you ever go to like a board game cafe or something, pick up Dominion. It's a ton of fun. Great game. Not as much math. Give it a shot sometime. You wrote something kind of weird down there, Gerbertap. Like, I don't know if that's what you meant to. Does it have a flag? I think it might, Brandon. I think it might have a flag on the front. Oh, no, here, let me point it to you. Let's just send this to everyone. It's a pretty well-known game. Like, there are members in my department who have played this game competitively. So it's sufficiently, strong enough to do that. But yeah, Gerbertap, try solving that for that again, because your equation there is a little off. I remember something about a flag though. I might just be misremembering though. Yeah, I'm trying to think about what you're thinking of though. Do you know what you're thinking of, Brandon? Do you know the game, or can you describe it? Sure. Oops. Strategy, eh? And I got, yes, Gerbertap, that looks good. Stratego. I feel like I've heard of this game, but I don't think I've ever played it myself. Huh. Interesting. I'll have to look into it. Yeah, I'm a pretty big board game buff, but I haven't really heard much about this, so I'll have to look into it. Kelly, yeah, that looks right. Yeah, that looks good. That's the sort of thing you want to do for sure. Okay, everyone. I think we're good then. Hopefully I answered most of you guys' questions. All right, I think we can call it quits then. So thanks everyone for coming. Yeah, no problem. Yeah, you too, everyone. Have a great night. and I will see you Tuesday. All right. Bye, everyone.